we are going to introduce you to a new number today. Okay? So we're going to graph y equals e to the x. And if you've never met the number e, that's not a letter. This is math class. I make up the rules, right? That's a number, right? The x is not a letter, it's a variable. The e is not a letter, it's a number. Find the number e on your calculator and estimate for me what is e approximately to 9 decimal places. E is not 0. You push the letter e. We're talking the number e. Find the number e on your calculator. You found the number e? Good. Good, good. So to 9 decimal places, the number e. Just e. We just want to find e. Okay, now the number e is a special number, just like pi is special, but you learned about pi a long time ago, and now you're learning about the number e now. Okay? So we want to graph y equals e to the x. It's an exponential graph. Just because the number is new and weird looking does not make the graph harder. What do all exponential graphs have? They all have an asymptote at y equals 0. What do all exponential graphs have? They have a point at 0, 1. Because e to the 0 would still be 1, just like 3 to the 0 is 1 and 5 to the 0 is 1. And if you plugged in 1, you would get 1, e. Perfect. And your graph looks just like your 3 to the x graph. And you would label the point 1, e, and you would know that when you label e, as far as on your, it would be somewhere between 2 and 3, a little bit closer to 3, because it's approximately 2.7. You see how the 1828, 1828 repeats? It doesn't do that after that. It's just to throw you off. But it does let you very quickly memorize e to 9 decimal places way faster than it took you to memorize pi to 9 decimal places. Go. 3.14. No. Disaster. Okay, so there's a little bit of homework. Make sure you get your pi memorized to 9 decimal places. Everybody knows 3.14. Then it's 1.5. Because that's what comes after 14. 15, right? And then it's not 16, because that would be too easy. Okay. So now we can graph y equals 3 e to the x minus 2 plus 1. Using our transformations. If you had a question like this, you would say, it's an exponential equation. The base is e, so off to the side, you might quickly draw your parent graph e to the x. And one of the things that we did prior with our other ones, do you remember we sort of like, okay, this is my parent graph, so I'm going to put a box around that just to make sure that that's not part of my transformations. And now I can label all of the transformations. The 3, vertical or horizontal? Vertical. Stretch, reflection, compression, translation. Stretch. You would multiply your y values by 3. The negative 2, vertical or horizontal? Horizontal. Stretch, compression, translation, reflection. Translation. We would go 2 to the right. And finally, the 1, horizontal or vertical? Vertical. Translation. 1 up. So we can take our key points, right? On our original graph, we had 0, 1, and 1e, and the asymptote y equals 0. Stretches and compressions first, then translations. Going through, we only have the 1 stretch, so we only have to multiply y by 3. We have 2 translations, so we need to go 2 to the right and 1 up. Where are those points going to end up? If you multiply your y value by 3, instead of 0, 1, you will have 0, 3. And instead of 1, e, you have 1, 3, which is a very hard word to say. 3. You have to kind of pause in between to make sure that you're not just saying 3. Okay. And now we need to go 2 to the right. 2 to the right would make this a 2, this one a 3. Up 1 would go to 4. And how do you do up 1 with 3? 3 plus 1. Yippee. And as a result, what's the only thing that's going to affect your horizontal asymptote? If it moves up or down, and since it moved 1 up, your asymptote is now at y equals 1. So we can graph this with our new points. When going to graph it, start with your asymptote, y equals 1. Then label your points. I would probably suggest starting with 2, 4. Just because you might have a better sense of where that is. 2, 4. And then we need to label 3, 3 plus 1. Wow, where would that be? So we have to sort of estimate, like E is 2.7, so if you took 2.7, multiplied it by 3, you'd get 8.1-ish. Plus 1 would be around 9.1. Anyway, so we've got 3, 3e plus 1, a little bit way up there. Maybe I should have started my graph lower down. But once I have those 2 points, the shape stays the same. And there we have our graph with our new favorite number. It's number. I'm not talking letters. Right? And yes, that number does exist. I know I could probably convince you that I made this whole thing up, but you could do the same thing. We could have a y equals pi to the x graph and do the same thing with pi if we wanted to. Yeah. They should, right? Well, they also don't teach decimals, right? You'd be stuck, like, and why do you have to start at 1? Who, when you count, who told you start at 1? Why can't you start at something else? Okay? So if I told you to count from 1 to 2 and don't miss any numbers. Oh. That would be 1. And then the next number would be 1 decimal 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. It would take a very long time. Okay, so if you haven't finished graphing questions 10 and 13 from 5.2, we're going to graph those right now.